So we met last lesson, or those of you at home hopefully met on Uplearn, the three reciprocal trig functions, and a reminder that if you can't remember which is which, look at the third letter. So the third letter of cosec is S, which reminds me it's 1 over sine. The third letter of sec is C, which reminds me it's 1 over cos. And the third letter of cot is T, which reminds me it's 1 over tan. A reminder, of course, that tan is sine over cos. And that means that cot can be written as 1 over tan, but it's also cos over sine. And so these questions here on page 152 in the Pure 2 book just ask you to take something that's a bit of a mishmash of our new reciprocal functions and the old vanilla sine, cos and tan, and just simplify it into something a bit more straightforward. So let's have a look at D as an example. So I'm going to leave cos and sine as they are, but the bracket, well, see what you get when you write cot as cos over sine, tan as sine over cos, and then you try and turn that into something with a common denominator. Have a go. Have a go at D. Have a go at D. So cot is cos over sine and tan is sine over cos. If I want to add those two fractions together, I need a common denominator. So the common denominator will have to be sine times cos. So if I want this to have a denominator of sine cos, I need to multiply top and bottom by cos. So that means this has got to be multiplied by cos as well. So it becomes cos squared. So that fraction becomes that. If I want this to have a denominator of sine theta cos theta, then I need to multiply top and bottom by sine. So this becomes sine theta cos theta. This becomes do we feel proof relief washing through us? Well, I don't know. We're multiplying by that and then dividing by that. It's the same thing. And sine squared plus cos squared equals 1. It all ends happily. So just have a look at E, F and G. See if you can distill it down. It won't always be as easy as something like 1, but see if you can distill those down to something a bit more simple. So you're replacing cosec with 1 over sine, sec with 1 over cos, cot either with 1 over tan or with cos over sine. You've got to be light on your feet, okay? Come on in, Arthur. So with E, it all simplifies down to sine squared plus cos squared again. This is effectively a fraction multiplication sum, isn't it? So we can write it as sine cubed x over sine x. So yeah, if that wasn't obvious, I apologise for not making that clearer. But yeah, so that becomes that, which then simplifies down to the sine squared, and ditto here. You get cos cubed x over cos x, which simplifies down to sine cos squared, so sine squared plus cos squared is 1. Here I've got, again, same thing. That is that, common denominator. So I can write it as a single fraction with 1 minus sine squared on the top. 1 minus sine squared is cos squared. So you end up with just cos A. That cos cancels out one of those two cos squareds. And I don't know if you got as far as G, but if you did, it simplifies down to cos x. So let's now move into what might be asked of us in an exam in questions involving these reciprocal functions. You know, I sometimes reflect on how far we've come from working out missing lengths and angles in right-angled triangles, which is where we first meet sine, cos and tan. You know, we are a million miles removed from that now, aren't we? We're now using trig in algebra, and that's, you know, that's because, you know, there are lots of particularly sort of naturally occurring things like movement in space and things like that, which when you try and describe it, you introduce trigonometry. I've got a friend who works for a company that makes helicopter components at Torrington, and he says, you know, the dynamics of a helicopter is all to do with trigonometry, because everything's spinning and rotating and twisting, and he says, yeah, it's all trigonometry. So we are asked to do one of two things, and this covers not just reciprocal trig functions, but trigonometry in A-level altogether. We're asked to prove, or we're asked to solve, and occasionally we're asked to prove and then solve. So we're going to look at problems involving reciprocal functions under those two sort of rough headings. And so we start with prove. Oh, hang on. Why does it do it like that? Sorry. So we're on page 152, question 4. Page 152, question 4. I'll make it as big as I can, but it's probably better if you have it in front of you. Page 152 and question 4. And you might say, well, hang on a minute, we've just done proof. Why, when we did proof, did you make no mention of these sorts of questions? And yeah, you're absolutely right. I perhaps should have done. But what we're dealing with here is proof by deduction. It's proof by deduction. And the triple equal sign is nothing to be afraid of. It's just you're saying this is not an equation that's only true for certain values. This is something which is always true. Proof questions in this context, I would recommend we always follow the same approach. You pick a side. You pick a side, and you try and make that side the same as the other side. So when we're doing proof questions, we don't tend to do things like take something from both sides or multiply both sides by something. What we do is we pick a side and deal with that side in isolation. So in this first question, I'm going to start by saying, right, I'm going to pick this side. So I'm going to consider, so we're doing proof of them, I'm going to consider the left-hand side. So that's my statement saying, right, I'm going to focus my attention initially on the left-hand side. I'm not going to deal with this like an equation where I'm moving things between the sides or doing the same thing to both sides. I'm just going to do what we were doing in the previous question with this. And I'm going to fiddle with it and tinker with it to try and make it look like that. Now, because in my mind, I know that sec theta is 1 over cos. So as well as thinking I've got to make it look like sec, I'm also thinking, well, if I can make it look like 1 over cos, that's the same thing. So there's no equal sign there, I'm just tinkering with this left-hand side. Okay, so let's leave the cos theta. I'm going to write tan as sine over cos. And at this point, it's a trick we've already used today, but it's a really important trick, so put a big star next to it. There is one thing. Here are two things. In order to turn those two things into one thing, I need to write them as a fraction with a common denominator. So I'm going to turn this into a fraction with the same denominator as that. I'm going to write it that's still cos theta, but it's now something I can combine with this side. I can now write it as and you know, there are numerous clever little tricks and techniques, but that trick, which takes two things and changes it into one thing, is really crucial. We've already met it earlier this lesson where we changed two fractions into one fraction with a denominator of sine cos. This one's a little bit more subtle. I turned it into a single fraction with the denominator of cos by just taking this, which is cos theta over 1, and multiplying to the bottom by cos. Okay? Does anyone feel proof relief coursing through their veins? Arthur, what can I replace the numerator here with?
1.
1 over cos theta, which is, at that point, I pull in the right-hand side. Okay? So when I hit that, I then say, oh, that's the same as the right-hand side. So with proof questions, in general, it's a famous thing, famous last words say you never do it. You tend not to transfer things between the sides or multiply both sides by the same thing. You pick a side and you try and make it look like the other side. And sometimes you realise you've picked the wrong side and you have to go back and start again. But there's no great danger. So go on, have a look at B and C and see where you can get with those. This is question 4, page 152. Perhaps I should just say, when I come to B, even though I'm considering the left-hand side, I'm making some little sneaky right-hand side notes. I'm just thinking, right, that is that, which is that. So if I can make the left-hand side look like that, I'm there. All right. So it's sometimes helpful, even if you're focusing your attention on the left-hand side, just to have a little tinker with the right-hand side to work out, what it actually is the same as. So if I hit that, I know I'm there. But I'll leave you to carry on. So here's that trick we've used before. We've got a fraction with sine theta as the denominator, a fraction with cos theta, so we're going to go for sine theta cos theta. This one, therefore, I need to multiply by cos theta, top and bottom. And this one I need to multiply by sine theta, top and bottom, which gives me cos squared theta plus sine squared theta on the top, which is 1. So you get 1 over sine theta cos theta, which I already know because of my sneaky right-hand side notes that that's what we're after. But I might then say, right, which equals 1 over sine theta times 1 over cos theta, which equals cosec theta sec theta as required. So with D, I did my little sneaky right-hand side note, so I knew what I was aiming for. I replaced my sec with 1 over cos, and then gridded it out. And I have to say, at that point, I was thinking, oh no, I've gone wrong, because it doesn't look very nice. You get 1 over cos, which is 1 times 1 over cos, and minus cos x over times 1 over cos x. The cos cancel out, so that's where you get -1, so there's no number there. But then I spotted, right, it's 2 things. I want 1 thing, so it's time to kick in with the common denominator trick. And that's not always obvious, I understand that. So here I turned this, which isn't a fraction, into a fraction with the denominator of cos x by just multiplying top and bottom by cos x. And then it all just sort of trickled down and ended happily. So does E end happily? So if we go for a common denominator with E, and please don't feel you always have the left-hand side is the one you focus on. So we've got cos x over 1 minus sine x and 1 minus sine x over cos x. So to get a common denominator, I'm going to have to multiply this side by cos x, top and bottom,
I've got sec, not sine.
and this side by 1 minus sine x, top and bottom, which gives me a single fraction with 1 minus sine x times cos x. And here I've got cos squared x. If I grid that out, I get 1 so I get plus 1 minus 2 sine x plus sine squared x. I'm happy with where this is going, but we shall see. I've got a sine squared plus cos squared, so they disappear to make 1. And there's a little sort of glimmer of hope here, because now I've got 2 minus 2 sine x on top. And that, I've run out of space, is 2 lots of 1 minus sine x. Bang, bang. Why is that not what I want? Oh, hang on. I'm still looking at the wrong right-hand side. That's 2 over cos x, which is 2 sec x, which is what I'm after. Sorry, I was still aiming for that. That's from the previous question, isn't it? As required. Thank goodness. Now I can imagine you being sat there thinking, this is just too much. You know, how am I supposed to know all these sort of little things? I mean, we're in another situation where it's just about practice and experience, and so far you've done 1, 2, 3, 4, maybe 5 of those. you know, when you've done 50 of those, you'll feel a little bit more relaxed about it. Hopefully. Oh, dear. We need to do solve, and we've only got 5 minutes. Let's just do one solve then. So so the other side of this, and don't think we've finished proof. No. We're going to be proving and solving pretty much constantly for the next few weeks. So let's just do one solve quickly. Let's do 5E, because that'll set us up nicely for 5F tomorrow. Not tomorrow, on Monday. So 5E. And look, I'm in degrees. I feel like cheering, you know, back in degrees. So I'm going to deal with this like a quadratic. It's a quadratic, and I know that's a bit lazy. There's a much better way of solving it, but I'm going to deal with it like a quadratic. So I'm going to whack that into my calculator to get answers for sec theta. So A is 1, there is no sec term, so B is 0, C is -4. Can I invite you to do that? It's not right, is it? I put 1, sorry. Yes. No shift sec button on my calculator, so what I then do is just flip it. And of course that simplifies down to 1/√3, doesn't it?
Sorry, isn't it over 3?
Oh, is it? Oh, right, so it doesn't simplify then. Thank you. Sorry. That's funny, I was talking to some friends last night about me and mistakes and bond. I'm sorry, I'm going to balls alone. And one of them said, "So do you like deliberately make mistakes so that to keep on saying?" I said, no. there's no need for deliberate mistakes. There are mistakes aplenty without it. And we haven't got time now. But what we would then do, we're dealing between 0 and 360, is we would shift cos both of those. I know this is going to give me 2 solutions, and this is going to give me 2 solutions. There'll be 4 answers altogether. Bish, bash, bosh. So we'll pick up with some more solving, and then I've got 2 new identities to introduce you to. It's all good. It's all good.